Hi class. In our first lecture in this section, what we did was we talked about what it means for a function to be increasing or decreasing. And then what we did was we worked two rather simple examples, right? We find the intervals in which f of x is equal to x squared is increasing or decreasing. You know, that was pretty straightforward. And then we did, this one was a little bit harder, a little bit of crazy algebra. We looked where f of x is equal to x times the square root of 9 minus x squared. We found the intervals; those were increasing or decreasing. And now let's actually do a simple trig one. Okay, very, very simple trig. So let's look at f of x is equal to sine of x minus 4. Okay, that's just sine of x, and then the minus 4 is not inside the trig function here. And let's just look on the interval from 0 to 2 pi. Okay, so just on that interval right there. Well, right off the bat, first thing you need to do is you need to find the derivative, right? And this is really easy. F prime of x, the derivative of sine is cosine of x. That's, the derivative of minus 4 here, or the 4 here is 0. So then you're going to find the critical numbers. So what you're going to do is you're going to set this cosine of x equal to 0. And you're just going to ask yourself, okay, where between 0 and 2 pi does cosine of x equal to 0, right? And we should all know that occurs at pi over 2 and at 3 pi over 2. And if you need some help remembering this, and some of the harder examples later on in this section here, you'll notice I put a unit circle up there because we're going to pick some ones that we might not know off the top of our head. So you can always have that handy as you work through these trig problems. Okay. All right, so anyways, going back here. So we've got our critical numbers, pi over 2, 3 pi over 2, and we've got the interval for this trig function we're looking over here. All right, so our intervals. You're going to start at 0. The first number you come to is pi over 2. Then my second interval, I'm going to pick right up at pi over 2. And then I'm going to go to 3 pi over 2, because that's the next number. And then my last interval, I'm going to go from 3 pi over 2 all the way to 2 pi. All right, so then you need a test value in here, right? All right, so pick a number between 0 and pi over 2. I'll just pick pi over 4. Between pi over 2 and 3 pi over 2, I'll just pick pi. And then between 3 pi over 2 and 2 pi, I'll actually pick 7 pi over 4. That's how I'll do that one. All right, so sine of the derivative, f prime of x. All right, so you're going to look. Our derivative is just cosine of x here, right? So f prime of pi over 4, it turns out, and I'll just help you here, like cosine of pi over 4 is actually the same thing as cosine of 7 pi over 4. And it's just the square root of 2 over 2. So we see that this is positive. F prime of pi, well, what is, cosine of pi? That's -1, so that's less than 0. And then I already spoiled this one. F prime of 7 pi over 4 is greater than 0. So what is our conclusion here? It's increasing on this interval, decreasing on this interval, and then again increasing on this interval. So we can just, firm it up and say, this function is increasing on 0 to pi over 2, and from 3 pi over 2 to 2 pi, and then it's decreasing here. All right. Let's take a look now at this crazy one here. All right, so this trig one was pretty, this was a very, very easy one, very straightforward one. I'll actually, later on in one of our final lecture, the third lecture for this section here, I'll do another trig one that might be, it might be a little bit harder. All right, let's look at this one. All right, so if I want to find the intervals, this function, f of x is equal to the square root of x times e to the minus x. All right, the interval is increasing or decreasing. All right, well, first off, what's the domain, right? You can't take the square root of a negative number. You get an imaginary number. So this is going to be from 0 to infinity. All right, again, if it helps, as I go to take the derivative, right? That's x to the 1/2 e to the minus x. All right, so let's find the first derivative. You need to use the product rule, right? So the 1/2 comes down, x to the minus 1/2 e to the minus x plus x to the 1/2. You still have to chain rule this, right? So the derivative of the inside here of negative x is negative 1 e to the minus x. So look what this is. This is e to the minus x all over 2 square root of x plus, or excuse me, minus the negative 1 there, my bad, the square root of x e to the minus x. Well, look what you can do here. You can actually, to make this easier, you can literally factor out an e to the negative x. I'm going to write this square root of x over 1. So what I would do here is common denominator, right? The common denominator here is 2 square roots of x. So what you can do is you're going to multiply this by 2 square root of x, and you're going to combine these two terms. So this is e to the minus x. So this is 1 minus. When you multiply this, you get 2, and square root of x is just x all over 2 square roots of x. Okay, this is what our first derivative is. Okay, so I want to find the critical numbers from this. Okay, by solving f prime of x is equal to 0. So e to the negative x times 1 over 1 minus 2x over 2 square roots of x. And that's going to be equal to 0. Well, look, you would just do the 0 product rule here, but e to the negative x can never be equal to 0, okay? So really what you're solving then, you're looking at 1 minus 2x all over 2 square roots of x is equal to 0. Again, if you want it to equal to 0, you only need the numerator to be equal to 0. And the value that you plug into the numerator here will not make the denominator equal 0. So again, you're just now solve, it's very simple. 1 minus 2x is equal to 0. You add the 2x over, divide by 2, and you get a very simple critical value here. You only have one of them, actually. So now we just need to take this and set up our intervals and go from there. So our intervals here, and I'm going to rewrite this on the next slide, so we can see what the pertinent information here is. Okay. So our domain. It was 0 to infinity. The first derivative ended up being, I'm going to write the simplified version here, okay? It ended up being e to the negative x times 1 minus 2x divided by 2 square roots of x. And our critical value was just 1/2 here. So we're going to set up our intervals now. You're going to start at 0. you're going to go to 1/2. And then it actually, then it only actually looks at here. It looks like it's just then 1/2 to infinity. You're going to need to pick a test value. So in here, the test value I'm going to pick is 1/4. And then in here, the test value I'm just going to pick is 1. Okay. So now you want to figure out what the sign of f prime of 1/4 is. Well, look, here's how I do this. All right. E to the negative 1/4, that's positive. 2 times the square root of 1/4, that's positive. So positive, positive. So all you're interested in is the value of the sign of the numerator here. Well, 2 times 1/4 is 1/2. 1 minus 1/2 was 1/2. So that's positive. Now look, f prime of 1. Again, when you plug 1 in here, it's positive. Plug 1 in here, it's positive. So 1 minus 2 times 1, that's negative. So this function, so our conclusion here, this function is increasing here, and it's decreasing here. So increasing on zero to 1/2, and it's decreasing on 1/2 to infinity. And let me load up my graphing calculator here and show you what the graph looks like just to verify it here actually. So let me load that up for us. So loading up the graphing calculator here. All right. This was our function. Okay. So I want to plug this into our graphing calculator. So I'm going to go y equals. It's the square root of x. And then it's e, so which is right there, raised to the negative x. And when I look at our graph, it's really hard to see, but when I zoom in, you can see here the function is definitely increasing for a while. And then let me zoom out actually here. You see the function's increasing for a while and then it starts decreasing. Yeah, that's what's going on. You're increasing until you get to x is equal to 1/2, and then you're starting to decrease there. And that's what we also saw when we did the calculus here. Okay, class, I'm gonna follow this up in this section, finally ending talking about the first derivative test next. And in the first derivative test, we're also gonna revisit this stuff.